And we got down to synthetic division. And so when we'll write the problem and then we'll set up. So 4x cubed. You want to make sure that you are in descending order. And if you're missing any terms, you have to fill in a 0. This one is not missing any. We start at x cubed, x squared, x to the first constant. So it's good. And you're going to set up your funny looking little division grid, backwards L. You use the opposite sign. So if this says -6, you're going to use +6. And then you take your coefficients. If you were missing any, you would have to put a 0 for that spot. Skip a row, bring your first one down. So you're going to multiply. Your 4 times 6 is 24. It goes in the next column. And then you combine what's your signs. This will be a -3. You're going to multiply again. -3 times 6 is a -18 into the next column. Combine these. 12 minus 8, that would be 4. And positive, so we'll multiply again. 4 times 6 is 24. Goes into the last column here. And then combine, so 24 minus 16 will give us an 8. So it should be good there. Now we're going to put it back together. Let's let the person in. All right, so now you're going to put your coefficients back. You drop 1 degree lower than where you were to put your coefficients back, to put your variables back on. So we started at x cubed. We're going to now have x squared. So we have 4x squared minus 3x plus 4. Whatever's in this last spot will be a remainder, and you write it back over the divisor. And the divisor was x minus 6. So that's what should go in our answer thing. 4x squared minus 3x plus 4 plus this fraction form. So that is a synthetic division. This one looks the same. There's no terms missing. That's the only thing to watch out for that I don't have in either example. If there is a term missing, make sure you put in a 0 placeholder. Okay, so I think one of those is enough. You guys let me know if you have any questions. All right, and we will just keep going. So I'm going to go to 34. We're down to the exponent sections. And oops. And this is to the -3. So it's going to pull in a few rules, and there are different ways that you can do this problem. I would probably start inside and work my way out, because you can do something with these y's. You can clean that up, right? And they will subtract. It's fraction form, so they're going to subtract. We'll keep everything else. So my -6, this will be y squared on top and z to the 4th. Right, and this is all to the -3 power. All right, and now you're going to take that down. It's going to apply to the numerator and the denominator. So my whole numerator and the whole denominator. Now, if you want to, because both of these outside exponents are negative, you can actually switch these two around. The only change will be the outside exponent will change to positive. Right, so this will go down. Everything inside staying the same. Outside exponent now will become positive. That was what shifting it did. This one's going to go up, and then its outside exponent becomes positive. So we still have to work those out. This one is going to give us z to the 12 on top, power to a power, keep the base and multiply. So keep the base and multiply here. So z to the 12. This one is a product to a power. So your 3 is going to apply to each one. So we're going to have negative 6 to the third and y squared to the third. Negative 6 to the third you're going to do on your calculator. It is going to be negative. If you're entering the negative, you would use parentheses. Parentheses, negative, whoops. No, I did the negative. Do parentheses, negative 6, close to the third. So exponent. So negative 216. Because the exponent's odd, you're going to get negative. 216. And for your variable, keep the base and multiply. And then that one should be done. You could have gone different steps. If you had chosen, you could have applied that negative 3 to each one to begin with. That would have been okay. Right, you should get to the same answer. It doesn't really matter where that negative is. They show it out front. That's fine. Everything else looks the same. All right, the next one looks a little easier. They give us the hardest one first, it looks like. This one does have negative exponents, but it's a simpler problem because no fraction. And so with it, if you don't have a fraction to begin with, I would go ahead and do any other rule. I wouldn't change anything to positive. So I would go ahead and apply that negative 1. It's a product to a power. Take it down to each one. So you have a to the negative 3 to the negative 1, b to the 8 to the negative 1. This one you'll keep the base and multiply. So you have positive 3. And this will give you b to the negative 8. Now I would clean up the negative exponent. Give me just 1 second. So now the a is good. It's going to stay. Your b is going to go to the denominator and the exponent changes to positive. And it went because the exponent's negative. That's what made you take it down. All right. Let's see. We have one more of these. So you are in a fraction form here. I would actually work both of these out. So I would work out this numerator, power to a power, keep the base and multiply. I would work out this denominator. 9 times 5 is 45 and it is negative. And then I would just switch these because they're both negative. So this one will go up, this one will come down, and now subtract top to bottom. So this will be x, equals x. 45 minus 24, 5 minus 4 is 1, and 4 minus 2 is 2. And it's done. Right. So looks like we're moving into some quadratic equations here, and we factored and used the zero product law to solve. So And we know this is a solved problem even if it didn't have the words because of the equals. So, and we know the exponent of 2. That's how we know it's this new kind. So a quadratic equation, so it's not isolate the variable, right? And so you make sure you have a 0 on one side, which we do. You're going to factor on the other side. So we're going to factor over here. And this will give us different signs when it is a negative. Split your x's. And we're multiplying to get 6, combining to get 1. I think that we will need 3 and 2. 3 and 2 multiply to give 6, and they subtract to give us a 1, and we'll want a negative 1. So since we want negative, that sign, whatever it is, should go with the bigger number. Right? So we'll double check. Minus 3x plus 2x gives negative 1x. So we're good. Now we'll set each one equal to 0. And solve. So this will be x equals negative 2. You're subtracting 2 from both sides. This will be x equals 3. You're adding 3 to both sides. So we have 2 answers, negative 2 and 3. And it already has the braces there. All right, we have one more of this kind. So p squared plus 12p equals 0. And it is a quadratic equation. It has the equals and it has an exponent of 2. So you make sure you have the 0. We do. And on this side, we need a factor. The only kind of factoring we can do right here is a GCF. There is a p in both of those. So we'll take a p out, and that will leave us p plus 12. It is a product, so we'll be able to solve. So we'll set this one equal to 0, and we'll set this one equal to 0, and solve. The first one's already solved. This one subtract your 12, so p equals negative 12. So we have 2 answers, a negative 12 and a 0. And all this was if you get a fraction, they want you to leave it as a fraction. Don't switch to a decimal, put a comma in between. The directions were probably more confusing than the problem. Okay, let's see. This one is a Pythagorean theorem problem, if you remember those. It is a word problem where you can make a right triangle out of the picture. So it says laptop computers are measured according to the diagonal. So this green line on their screen. A 15-inch laptop has a screen that is 9 inches tall, and they want to know how wide is it. So they want this bottom length. So they're only looking at half of this rectangle. They are looking at this piece. All right, and here's your 15, which they gave you, and they gave you 9, and they want you to find this length. Right? This is Pythagorean's theorem. A squared plus b squared equals c squared. The c has to be the hypotenuse, which is always opposite the right angle. The other two are a and b, and it doesn't matter which is which. So we'll call this a and b. So it's b that we don't know. Plug in what you do know. So we know a is 9, and we're going to square it. We don't know b, and it gets squared in the formula. We do know c, and we're going to square it. So we'll do all the math we can. Sorry. Not what I wanted to do. I was trying to just move it. Okay, we're going to type in it like it is. 9 squared we know, that is 81. And 15 squared is what I need to do on here. So 15, you could use the squared button, or you can do to the second power. is 225. And now you're going to isolate the b squared. So subtract your 81 from both sides. So get b squared equals 225 minus 81, 144. But we don't want b squared, we want b. And so we'll take the square root of both sides. And when you do this on your regular equations, you get plus and minus. Because it has length, we're not going to want the negative one. So we're just going to take the positive square root because it's a real world problem. And it's a perfect square. You could have put it in your calculator. It will give you 12. So make sure you can do that. So second square root, whoops, I picked the wrong button. I picked any root. So second square root and 144, close, enter, 12. Okay, so it came out exact. And we didn't have to approximate to 2 decimal places. So some of the problems might not come out even. Right? This is another example of the same thing. I think we can probably skip it because it's the same skill. The x is your c. So you're going to do 3 squared plus 8 squared equals x squared. Are you guys good with that, or do you want me to do it? Somebody let me know in the chat. Okay, so we'll skip it then. All right. So 41. Says solve the given quadratic equation. Simplify your answers completely. Leave your answer in exact form, so no decimals. Enter answers with commas in between. Okay. So we have a quadratic equation, 2k squared minus 3k minus 3 equals 0. All right, and remember with quadratic equations, if it will factor, you can try to factor and use the zero product law. If it's set up right with just something squared equals a constant, you can use the square root method. And if neither of those, you can use quadratic formula. I'm going to use quadratic formula on this one. It might factor, it might not, but I don't like to do the ones with the number in the front because you are taking a chance that it won't factor and then that was wasted. All right, so if you're going to use quadratic formula, you pick off your coefficients. So my A is 2, my B is negative 3, and my C is negative 3. You need to make sure that you know this formula. X is equal to negative b plus or minus the square root. B squared minus 4ac, whole thing is over 2a. And then we plug in to this formula. So x is equal to negative b. B is already negative, so this will be a positive 3 plus or minus. This will be a negative 3 squared. You need parentheses, so the negative goes to the power. 4 times a, which is 2, times c, which is a negative 3, all over 2 times a, which is 2. And then you're going to clean up, so we're going to work under the radical here a little bit. So 3 plus or minus. Negative 3 squared will give you a 9. And I always look at this next piece and see, what's my sign going to be? I have 2 negatives, so it's going to be plus. Right, so 4 times 2 is 8. 8 times 3 is 24. And I can also work the denominator here. All right, and we can go ahead and finish underneath. 9 plus 24, 9 and 4 is 13. So this is a 33 over 4. Now you have to think if that 33 doesn't reduce. 33, if you break to primes, is 3 times 11. And you didn't get 2 copies of anything, so it won't reduce. So this should be our answer. They're going to make us split it. You will not have to split it with the multiple choice answers. So it will be 3 plus the square root of 33 over 4. And 3 minus the square root of 33 over 4. Just because of the software, that's how you have to enter. So that's an example with quadratic formula. Let's see what we have next. All right, so this looks like a quadratic equation. We have an equals, we have an exponent of 2. So step 1 would be get a 0 on one side. So you're going to have to add a 6. All right, and then one thing that I do see here is there is a GCF in there. There is a 3 in all those pieces, so I would probably take it out. That leaves me 3x squared plus 4x, and 3 into 6 will go 2. All right, you have a choice here. You can try to factor this, or you can take it to quadratic formula, and you could have taken it to quadratic formula up there. Just thinking for a second. 3 times 2 is 6. 6 and 1, 4. And that's not going to factor from there. So, one trick you can do, since I did factor out that 3, I can actually divide it out. And this one, it's gone. Now, it didn't have a variable. If you had a variable, you couldn't do it. Right? And 0 divided by anything is 0. So it just makes it a smaller problem. But I think you still are going to have to go to quadratic formula. Just doing it quick in my head, if we did that AC method, 2 times 3 is 6. Multiply to get 6 and combine to get 4. There's not a choice there. 6 and 1 or 3 and 2. So I think quadratic formula. So we'll do A equals 3, B equals 4, and C equals 2. And so X is equal to negative B, so negative 4, plus or minus the square root, B squared minus 4 times A times C, all over 2 times A. And so we have negative 4 plus or minus 4 squared is 16. And this is minus 4 times 3 is 12 times 2 is 24. Over 2 times 3 is 6. All right, and this is giving us, we'll work this radical out. So we have negative 4 plus or minus, and this gives us a negative 8. This radical is going to clean up. Let's see if it'll give me a little bit more space. It's not wanting to. All right, I'm going to do this radical on the side. Because of the negative, you're going to take out an I. So we're going to take the I. The 8 gives us 2 times 4, and the 4 gives us 2 more 2's. So for one group of 2's, we can take a 2 out. So we're going to have a 2I on the outside and a 2 on the inside. That's just for your radical. All right, so let's see if it's interested in giving me more space now. You know what? I'm going to not play this game. I am going to get more space. And then I lost the whole page. Lovely. This is where I was. Okay. So we said that this one is equal to 2I times the square root of 2 over 6. And if you get a common factor in this triangle around the plus and minus, you have to divide it out. We have a common factor of 2 there. So we're going to do 2 into 4 goes a negative 2. 2 into this 2 will divide it out, but you still have the I in the radical. And 2 into 6 will go 3. You won't reduce this because you're going to leave it as one piece. If you separated it, you would reduce it. But you're going to write negative 2. If there was a 2 here or something, we could reduce, but you can't just reduce this. You know what? I didn't do it right. I had to divide all 3 of these by 2. 2 goes into 4 2 times. 2 goes into 2 1 time. 2 goes into 6 3 times. Okay, better. Okay, so I have negative 6 plus I square root of 2 over 3. And I have negative 2 minus I square root of 2 over 3. All right, and that is here. And they actually separated it. I believe this answer would also be just fine. They just put the 3 under each piece and made separate ones. You could have done quadratic formula from the beginning on that problem. Right. I am going to skip 43. It also looks to me like it would be quadratic formula. So we've done 2 of those. We'll skip that. Let's look at 44. This is the first one that is good for square root method. And I'm sorry about the letters this computer uses. A J. Okay. I would like an X there, please. All right. So this is a quadratic formula, but it's in the form to use the square root method. If you have x squared equals some constant, right, then x is equal to plus or minus the square root of whatever that is. And so we have something squared equals a constant, so we'll take the square root of both sides. Right, and the radical and the exponent cancel each other. So I have 7j minus 7 equals plus or minus square root of 16 is a 4. And so now we're going to finish solving for j. So we're going to add a 7 to both sides. Do it in front of the plus and minus so that you can pick up both signs. So 7j equals 7 plus or minus 4. That is a 7, doesn't look like it. And now we're going to divide by 7. So, because these are plain numbers, they don't have a radical or they don't have an I, we will actually work this out. So we will do 7 plus 4 is 11, and it goes back over 7. And we'll do 7 minus 4 is 3, and it goes back over 7. So this problem was good for square root method because you had just something squared equals a constant. Is why you use this method. And it's faster than any other method there. This one, 45 is another, so we'll do one more so you have an extra one. It is set up to use this method. You have something squared equals a constant. So take the square root of both sides. Remember, when you do that, this side gets plus and minus. Right, this one gets your exponent off, so leaves u plus 8 equals plus or minus square root of 46. 46, let's see if we can clean that up a little bit. We'll use our calculator. And we know there's a 2 in it, so 46 divided by 2. And that's actually all you can do, because 23 is prime, 2 is prime. It doesn't go any lower. And so there was no square in it. That's as much as it can do. So all you have to do is move your move your 8 and put it in front of the plus and minus. We can have a 9. All right, so u equals negative 8 plus or minus square root of 46. And you will leave the answer there. Now this homework set has us split them up. So it's going to be negative 8 plus so this is very weird the way they ask for these. So it's negative 8 plus, and B is this, it's going to be 46. Not a really great question. Hopefully your question will be better on the final exam. I'm going to just make a quick note about that problem so that I can take it out for future classes. All right, in the review, 45. Okay, just the way they ask it. I mean, the standard way, you would want to, this is your answer. Okay, and if you split those, that would be fine. Negative 8 plus this, negative 8 minus this. But the way they ask it there is weird. All right, so we're moving out of quadratic equations. You don't want to mix the ones we just did up with the ones we're looking at now. All right, these are equations that have a radical. Right, and so first step is isolate your radical. So you're going to go on that side and take off anything besides the radical. So I'm going to take off the 6. And so I get square root of m plus 5 equals 4. And now you're going to raise both sides to the power of the index. The index is 2 because it's a square root. So we are going to square both sides. And that cancels your radical. So squaring and raising to the second power are inverses of each other. Right? And then you're going to subtract the 5. To isolate your variable, m equals 11. You do have to check the answers on these because sometimes you get extra answers. So you have to go back to the original. Square root of 11 plus 5 plus a 6, is that equal to 10? This is a 16. Square root of 16 is 4. 4 plus 6 equals 10. Yes, it does, so we're good. Remember, your answer was here, 11. That was just our check. Right, 47. This one is also an equation with a radical. First step is you have to isolate your radical. So you're going to add a 3 Now, if you're paying close attention on this one, you don't even have to do it because it's not going to work. And the reason is because when you take a square root, now if it's a different root, it would be okay, but a square root is not going to be negative. It's always going to be positive because of how we defined it. And so this one is going to be no solution. If you went through your steps, okay, so we know that, and that is the answer. But if we went through the steps and we squared both sides, right, this would get rid of your radical. And this gives us a positive 16. And we would subtract 2. So we get x equals 14. But you would have to check in that original. So 14 plus 2 minus 3, does that equal negative 7? This is square root of 16, which is a 4. 4 minus 3 is a 1. It is not negative 7. So whether you realized it up here, a plain square root, once it's isolated, it is not going to give you a negative number. But if you didn't catch it there, you could still keep going, do the steps, but in your check, you're going to see this is not going to work. So this one is, it does not exist. All right. So kind of moving out of that material now into those rational expressions. And in that chapter, you had to, first we have to simplify, which means factor first and cross off. All right, and hopefully they didn't give us mean ones. So we're going to get a bunch of factoring practice in this. So on the numerator, the only thing you can do to try is you can do a GCF. And the reason is because your exponent is 1. So that's your only choice. So we can take out a 2, and this leaves x minus 9. All right, your denominator is a trinomial, so we'll try to do it this way. This says do like signs, both minus. And 54, 9 and 6 pop in my head. That multiplies to give 54, and it adds to give 15. It's going to work. So we have x minus 9, x minus 6. Once you have everything factored, you match up and cross off. So we have 2 over x minus 6 is our answer. So there's a 2x minus 6. So factor everything and cross off what you can. I'll skip this one. It's going to be the same. You've got 2 trinomials to factor, match up and cross off. Right, your division and multiplication. We'll do the division. These take a lot of time, because you have to factor all 4 pieces. That's 4 problems. Division, you change to multiplication, so you have to invert the divisor, then you cancel. All right, so multiplication, you don't flip it over. So the division has one more step than multiplication. All right, so we got to factor all 4 problems. I'm going to factor and flip on the same line. So I'm going to take care of this, and this one's going to flip over because it's a lot of writing. All right, so this one is a trinomial, 2 sets of parentheses. Negative at the end says do different signs. Split your y's. Multiplying to get 56, subtracting to get 1. That's going to be 8 and 7. Now, you want to get a negative 1, so you need to put your bigger number with that sign. So 8 here, 7 here. Check and make sure it works. There's minus 8 plus 7 gives a minus 1, so we're good. All right, denominator, also a trinomial. All right, this negative at the end says different signs. Split your y's, multiply to get 4. So 1 times 4 or 2 times 2, subtracting to get a 3. So let's do 1 and 4. We want minus, so that needs to go with the bigger number. Let's check. Minus 4 plus 1 gives me minus 3. So we're good. All right, this is times. All right, this one's going to the numerator. This is a difference of squares. 2 terms minus exponent of 2 and perfect squares. So y plus 4, y minus 4. You want to be that fast with that one. Right, one more trinomial to do. So we'll split the y's. This says do different signs. And we're multiplying to get 32, combining to get 4. How about 8 and 4? And you want negative, so that side needs to go with the bigger one. So we want a plus 4 and minus 8. So minus 8 plus 4 gives me minus 4. So it is good. All right, all of that worked, and now we start canceling. So you can go on your diagonals if you get anything that matches. So these two match. You can try this diagonal. The y minus 4 matches. You're also allowed to go straight up and down. Now these don't, but these do. All right, then you put it back together, and the final answer is y plus 7 over y plus 1. Notice we did change from division to multiplication by flipping this second one over. And then that's how you would do a multiplication. You factor and cancel. So that's our answer. I am going to skip the next one because it is a multiplication. So factor first and cross off. Right, and we're down now to addition. So 52. And it has a variable, so you can't really do it on your calculator. If it's just plain numbers, you can. And so you have to pick a common denominator. And both of these would go into 21. So we're going to use a 21. And you have to put on the part that's missing. So we will bring down what we have. We'll just get a little more room here. I want to get a 21, so I am missing a factor of 3. You have to do numerator and denominator. So that gives me 15 over 21. The next one, I'll bring down what I have, and I want a 21. So this one is missing a 7. So I have plus 7v over 21. Now the rule is keep your denominator, combine the numerators. They will not really combine. One has a v and one does not. So that is all you can do to it. All right, we'll go ahead and do the next one, 53. All right, for your common denominator, you're going to have both of those because they're totally different. Once they have a sign in, you have to keep the whole thing together. So this one is going to need, I'm going to bring down what I have. I need more room here. All right, it is missing the x minus 3, so it's going to need an x minus 3 over x minus 3. And this one, I'll bring down what I have. It is missing the x minus 1. Now, before I really work all this out, I'm going to go ahead and remember what happens next. I'm going to keep the common denominator, so I really don't have to multiply it out. I can keep the factored form, and that will save me some time. The numerators combined, so I have to multiply those out. So 1 times this is going to just give me x minus 3. And this one, so it's a plus 3. Distribute it, so we get plus 3x minus 3. Now those can go together, so we have 4x minus 6. And we have one more step. We have to see if this will reduce. You can simplify a little bit on your numerator. You can take out a 2 GCF, but it did not match anything in the denominator. So it would have been okay to keep this answer. It should accept either of these answers. You go this thought process because if it would have matched either one of these, you would cross off. It did not, so it doesn't matter. You could have left it here. Right, and so they left it here because they knew. All right, next we have complex fractions. And this is where you multiply through by the common denominator. Right, so your common denominator is going to be x minus 11. You're going to multiply by it up here and down here. So we really multiplied by a form of 1. Now this problem is really nice because it's going to just cancel that whole denominator out, and this one cancels that whole denominator, and the answer is 7 over 15. So that one is real pretty. The other one, and I'm sorry that print is so small. We need to see if we can make that bigger. And so your first job is to find the common denominator for all the denominators. And so for our numbers, we have a 4 and a 5. The common denominator for them is a 20. And we need an A. We only need one. Both of those will go into the same one. So I'm going to just distribute this through. I'm going to put it beside every fraction. That's like doing it on the top and doing it on the bottom. I just like it right beside them. The other just had one fraction. That's why we didn't have to do it. It didn't have multiple pieces in it. This one, it just had one fraction up here. So that's why I go ahead and put it by each piece. And then you're going to clean each of those 4 up. So my first one, the A goes off, so I have 20 times 1 is 20. And here, my 4 will go into 25 times. So I have 5 times 3 is 15 and an A. Right down here, your A goes off, and there's a 20. And 5 will go into 24 times 4 times 2 is 8A. All right, and let's see if there's anything we could do. We could try to reduce up here. We could take out a 5, and 5 will go into 24 times. Leaves 4 plus 3A. And down here, we could take a 4, and 4 will go into 25 times. And 4 will go into 8 2 times. So it did not reduce, so we could have left it right here. Make sure you don't just cross off these 20s. You are not allowed to do that because of the signs in between. So this is 20 plus 15A. Your order doesn't matter. And this is 20 plus 8A. All right. So we are down to those, this looks like a start to say a system question. This is back to actually word problems from the beginning of the course. So this is a percent word problem, and I think you do have one of those on your final, where you have to find the original. So remember, it is original, so it's an increase or decrease problem. So original, it's plus if it's increase, it's minus if it's decrease. So like if it's on sale, it's minus. Equals the final. And this piece right here is percent times your original. All right, so Joyce paid $36 for an item at the store that was 55% off the original price. They're asking us original. We don't know it, so we'll have to use a variable. That's what a variable's for. Okay, this next piece, percent times the original. Your percent is 55% off, so 55%, you have to switch it to a decimal, so drop your percent, and it's 0.55 times the x. So your x is also in this piece, equals your final, and they had to give that to us, 36. So that's your setup. This coefficient's a 1, so 1 minus 0.55, just do it in your calculator. 1 minus 0.55 equals 0.45. Equals 36, and then you'll divide. I would also use the calculator for that. So I have 36 divided by 0.45 is 80. Now you can look at these and see if it's a reasonable answer. All right, so it was $80. It's 55% off. 50% would be half. That'd make it about 40. It's a little bit more than that, and it's 36, so that's reasonable. So we should be good there. So you need to remember this formula and how to find the original. There we go. And they gave us one more of those because they thought that might be tough. Let's see how we're doing for time. We're good. So computer went on sale for 7% off. The sale price is given is this. What was the original? So again, you're looking for the original. So this is going to be original. It is on sale, so it is minus your decrease or your discount equals the final. When you don't know something, that's what you call X. Your decrease is your percent. So it's 7%. Drop your percent and go 2 places to the left. So 0.07x. My final is 558. Remember, these are like terms, and don't forget your coefficient here is a 1. 1 minus 0.07. You can go to your calculator. It's going to be 0.93. So 0.93x equals 558. And we'll do that on the calculator. So we have to divide by 0.93. So 558 divided by 0.93. And we're good. X equals 600. Very good. All right, 3 more to go. So 58, this is a systems question that you're going to solve, and this is a nice standard one, so one like you might see on your test. You are going to make 2 equations, and normally you do one with adding up all your objects. So in this case, it's going to be people. And the other one you're going to do with money. All right, so we'll kind of keep that in mind to make our two equations. So it says the admission fee at an amusement park is $1.50 for children and $4 for adults. All right, so let's let X equal the number of children and Y equal the number of adults. And if we add those up, that is going to be our total people, which is there were 358 people in the park. All right. Then we'll use total money. So the price for each one times the variable, which is the number of them we have. So the children was $1.50 or $1.5 times X plus the adults were $4 times the number of adults we have, and this should equal our total money, $9.62. And there you have a system of equations. You can do it by elimination method, or you can do it, it's pretty easy to isolate a variable in this one. Either way is fine. I think I'll isolate one. So I am going to isolate the Y because this one has a decimal in it. All right. So if I'm going to isolate the Y here, I'm going to subtract the X. So Y equals 358 minus X. Right? And I did it backwards. I should have gone the other way. I was trying to avoid that decimal. All right. So instead of my Y, using parentheses, 358 minus X. And then we're good. So we have 4 times 358. And I'll bring this 1.5 down first. So 4 times 358 is 1432. Minus 4x equals 962. Put your x terms together. So 1.5 minus 4 is negative 2.5x. Don't be too worried about that negative. All right, now we're going to subtract 1432 from both sides. So 1432 minus 962, and that will give me negative 470 because I know the larger. Now divide by your negative 2.5, and this is why I said don't worry about that negative. It will divide out because we know we're not going to get a negative number of people. But because we had negative on both sides, it cleaned up. So I'm getting the two negatives here give me positive. I'm going to do 470 divided by 2.5 gives me 188. Now, we're going to have to substitute that. We said X is the number of children. So I have 188 children. We have to solve for Y. So we are going to substitute this back into, you could do it into this one, will be fine. So Y will be 358 minus 188. $170. All right, and it's important up here to have your words with it so you know how to answer. So X was the children, Y is the adults. So this one is adults, 170 with the adults, and this will be the children. All right, the number of children should be 188. The number of adults, 170. And there we go. That's a nice system of equation problem. All right, we should have time to do one of these. These are the linear inequalities. that are in two variables, so they're going to go on your grid and you're going to shade half of it. So remember, the first thing that you do is decide, is it solid or dotted? And you have an equals underneath, so this one is solid, right? Next, you are going to graph y equals x minus 2 any way that you can. This one is nice for slope, or you can plug in points, right? I'm going to use slope. So your coefficient there is a 1. So my y-intercept is -2. I would plot that first. My slope is 1 over 1. Go up 1 and over 1. So I'm going to plot that and then do a test point. Let's try and get a little bit more space there without making a mess of my thing. All right, and it is going to, that's okay, I can go ahead and plot that much. All right, I said it's going to be solid, so I need this tool. And so I'm going to plot -2, and I'm going to go up 1 over 1, and I'm going to click. Now, it shades just if you move from one side to the other, but I have to decide which side gets shaded. So I'm going to do a test point, one that's clearly not on the line. So I'm going to test 0, 0. In the original, so this is x, this is y. So 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to -2. That is true. So you're going to shade the side that includes your test. All right, and right now I haven't clicked yet, so the mouse would move at either place. But 0, 0 is here, and so I want that side. So now it'll stay on that side. I just clicked, is all I did to make it stay. And there we go. They're happy with our answer. Let's see if this one looks any different. Not a whole lot different. You could graph it with intercepts, or you could move it around. It doesn't really matter. We have time. We can squish it in. All right. 2x minus 8y greater than or equal to 16. Check your inequality symbol. It is going to be solid because there is an equals underneath. All right. So you can use intercepts are nice, or move it around and use slope. I wouldn't just pick random points, right? So if you want to use intercepts, and they're nice when you have x and y on the same side, that is just a little table, and you're going to choose 0. So if I choose 0 for x, I plug it in. I'm doing it now as if it were equals. And this is gone, so I have -8y equals 16. Divide by -8. So y equals -2. Right, then I'm going to switch and put 0 in the other one. Right, this one's gone, so I have 2x equals 16. Divide by 2. So x equals 8. So those 2 points can draw my graph. I said I want the solid tool, and I want, so this was 8, 0, and 0, -2. Don't go over, go down 2. Right, then I have to decide which side do I want to shade. All I'm doing is moving the mouse there. So you go back to the original and you do a test point. 0, 0 is good again because it's not on 0, 0. All right, so we plug it in. 2 times 0 minus 8 times 0. Is this greater than 16? Well, this is 0 minus 0. This is not greater than 16. So you don't want the side with this test point. You want to shade the other side. And so you're going to go to, here is 0, 0, so you don't want that side. Any point on this side you're going to click, and if you tested that point, it would make it true. And there you go. All right. We're going to stop there, and we won't have a session on Thursday. You can just keep doing your practicing now and get ready for your final exam. Get all your homework wrapped up. Okay? And you can email me if you have any questions. You guys have an awesome day. Thanks for coming. Thank you.